Figure 10 shows a girl doing an experiment to determine her power output by running to the top of some stairs. This question involves an experiment to determine the power. So we have to remind ourselves that power is equal to energy divided by time. But it has to be energy transferred. And it says, so here's a diagram showing us that the girl started here, she ended here. So what would happen in this situation is her chemical will change into Ke, and her Ke will change into GPE. Now they've given us some information here. It says the mass of the girl was 60 kilograms. So this is her value of mass. The height of the stairs was 175 centimeters. This is the value of h. Now remind yourself, you can't use height in centimeters, so you will have to perform a unit conversion here. So 175 divided by 100, and now this is in meters. The girl ran to the top of the stairs in 1.40 seconds. This is the value of t. The gravitational field strength is given to us as 9.8. Says calculate the power output of the girl. Let's write down the equation. Power equals energy transferred divided by time. Now, in this case, I don't know the value of energy transferred directly, but like I said here, it's the chemical in the girl's body that will change into Ke, and it will then change into GPE along the track. So in this case, we can work out the value of GPE. That's the energy transfer that has taken place. To work out the value of GPE, we'll have to change this energy transferred section into its equation, which is mass times gravity times height. That's the formula for calculating GPE divided by time, and that will be like. Once you've done this, all you have to do is plug in the values and solve, and we'll end up with the answer. So we can write down, instead of mass, I'll write down 60. Instead of G, I'll write down 9.8. Instead of height, I'll write down 1.75 divided by 1.40. If you plug these values in your calculator, you will end up with the answer, which is 735 watts. This is the value of. Next part says the total power output of the girl was greater than the answer to question 9.1. And that is true because we are only assuming that the entire amount of chemical energy in her body got changed into GPE when she got here. But in reality, some of her chemical energy will also be lost into the environment as thermal energy. So we just have to say some energy is lost into the surroundings as thermal energy. Now it's a 2 marker, so we need to write down one more statement to get another mark. So let's quickly have a look here. So when she moves from this location to that location, by the time she'll get here, she will also have some Ke, but we are neglecting that when we calculated our power. So we can say girl also has Ke when she reaches the top. Next part says a boy took more than 1.40 seconds to run up the same stairs. They took more. The power output of the boy was the same as the power output of the girl. Which conclusion can be made about the boy's mass? So I'll pick up the same equation from this part, and we just have to consider this. M times G times H over T. Now they said the power did not change, so this is still the same. Remains same. These two values also remain same. So for the power output to stay the same, if time increases, that means the mass also has to increase. So the answer will be